So this is our first page of our packet. Yesterday we learned all of these different rules of exponents, including the product rule. When you have the same base being multiplied, you add the exponents. Product to a power rule, power to a power rule, and yesterday we did go over the quotient rule and a quotient to a power rule, but I am just going to talk about it again because this is what we're going to be practicing today. So the quotient rule, which you already have in your notes, but again, it is when you have a division problem, which can be written in fraction form, like a to the b power divided by a to the c power. If you ever have any numbers that have the same base, meaning it has the big number on the bottom is the same for the numerator and denominator, and they have different exponents or even the same exponents, as long as they have the same base and if they're being divided, to simplify this, what you do is you take that same base and leave it the same way that it is, the same number, and you subtract the numerator exponent minus the denominator exponent. So anytime a problem looks like this, the same base, we can pick any number, 5, let's say to the third, over 5 to the second power. These numbers here, the 5 and 5, have to be the same. If you ever have like 5 to the third power over 2 to the third power, you cannot do it. It only works if the base numbers are the same. If they are the same, then to simplify this, what you do is you leave the 5 the same, and you take the numerator exponent 3 and subtract the denominator exponent 2. This would simplify to be just 5 to the first power. In this case, it would just be 5. And the reason why this happens is when you have exponents are just telling you how many times that number is being multiplied by itself. 5 to the third power is the same thing as 5 times 5 times 5. Over 5 to the second power is the same thing as 5 times 5. When you have division, if you have the same number in the numerator as you do in the denominator, they cancel out. Like this 5 can cancel out with this 5 cancels out with this 5. I'm only left with 1 5 left. That's 5 to the first power. That's where the quotient rule comes from. It only works when the base numbers are the same, because when you have the same base number, that means that number is identically the same, so that's why they would cancel out. In fraction form, whenever you have the same number in the numerator and denominator, they cancel out to be 1. That's why the quotient rule works, but it only does work when the base numbers are the same. And then the last one that I want to just revisit again is when you have a quotient to a power. That means you have any fraction number, and the quotient just means divisions, and a fraction is division. So any fraction number like a over b, if a fraction is ever raised to a power, like in this case I'm going to use a variable c, what you can do is to get rid of the parentheses, you would distribute essentially the power of c to both the numerator and the denominator. And you distribute that with multiplication. If that variable already had, or if that number already had an exponent, you would distribute it with multiplication. So for example, if we had something like 2 to the third power over, let's say 5, and we're going to raise this all to the second power. To get rid of the parentheses and use the quotient to a power rule, what we do is we take the power that is being, like that the fraction is being raised to, and we distribute that to both the numerator and denominator exponent of the fraction. You do this through multiplication. So 2 to the third power already has an exponent of 3 here. So when we distribute the new exponent 2 to the current 3, it's done through multiplication. So it's like multiplying 3 times 2, that's the same thing as 2 to the 6th power. The denominator 5 has an invisible power of 1 right now, so it's like it's just going to turn into a 2, but what's really happening is that the 5 already has an exponent of 1, and 1 times 2 is 2, so this would turn into 5 to the second power. Now, that would be your final answer. You would not be able to use the quotient rule and simplify this further. Why would you not be able to use the quotient rule to simplify 2 to the 6th power over 5 squared?
Not the same number.
Right. And what number is not the same?
The big one.
Yes. So the big number here, the base numbers are not the same, so we could not then use the quotient rule to simplify it further. That would just be the answer in exponential form. So we went over these rules yesterday, but I did just want to go over them again because now we're going to be practicing problems like that. So if you flip over, if you haven't already, to example 2, we now have a series of questions that are asking us to divide exponents and use the quotient to power rule. So when you're simplifying exponents that are in fraction form, you are going to be doing two things essentially. You're going to be looking for first coefficient numbers. That's like your numbers in front here, the 14 and the 7. And you're going to simplify any fraction numbers like you would normally. Like if I gave you a fraction and I said simplify 14 over 7, you would simplify that to be 2 because 14 divided by 7 is 2. So you're still going to use the same process for simplifying fractions, but then you're also going to be simplifying exponents with our new rules here. So when we simplify the coefficient numbers, the 14 over the 7, that simplifies to be 2 over 1. So when we go to simplify this, you would put the 2 on the top. You don't necessarily need the 1 on the bottom. Do you need this?
Yeah.
Sorry. So you don't necessarily need the 1 on the bottom. You could put it on the bottom if you prefer. I don't usually do that. I will just put the 2 on the top. But the reason why it will be on the top is because it equals and simplifies to be a whole number, which is 2, also known as 2 over 1. Okay, and then the next thing we would do is look for the variables. I have a to the 5th, b to the 3rd on the top, and a squared, b squared on the bottom. You can only use the quotient rule when you have the same exact base numbers. So we have two bases in this problem. We have a's and b's. So I will simplify the a's first. So I'm looking at a to the 5th over a squared. A to the 5th power is a times a times a times a times a. So 5 of them. A squared is a times a. So if you think about what's happening when you have a problem like this, each pair of a's cancels out on the numerator and denominator, so you can see what's going to be left, and hopefully you can start to see that from the actual exponents. The quotient rule, without having to expand it and show your work this way, the quotient rule just says if you have something like a to the 5th power over a squared, since the bases are the same, you take the exponents and subtract them from numerator to denominator. You have to do the numerator minus the denominator, 5 minus 2, and that's how many of your base numbers are left. So we're going to have 3 as our new exponent. You might be wondering, well, where does it go? Does it go in the numerator or does it go in the denominator? Well, in this case, because there are 3 more a's on the top than there are on the bottom, the a to the 3rd power would be on the top here. So it would be a to the 3rd power on the top. Once we get to the next section and we'll have negative exponents, you'll see what will happen when that does occur. But whenever you have a positive number of exponents left, that means that they're going to be on the top of the fraction. And then the last one is to simplify b to the 3rd power over b squared. So if you think about it this way, you can think, okay, b to the 3rd power is b times b times b. B squared is b times b. So you can visually see what's happening and you can see the cancellation and see how many b's will be left. Or you can just memorize this quotient rule and realize if there's 3 on the top, 2 on the bottom, you'll do 3 minus 2 and get 1. There's going to be b to the 1st power left. You can put the 1 if you would like. You don't have to. You can just put b, a plain old b with no exponent, because even though we didn't really talk about it ever, anytime you have a plain variable with no exponent, there actually is an invisible 1 there. So the final answer, without having to include things that don't matter, because I don't have to put this, I don't have to put this, the final answer would just simplify to be 2a to the 3rd power times b. So I don't need the over 1 fraction because anything over 1 can just be taken away. And I don't need the little exponent of 1 here. I can just drop it to show just b. So that's how you use the quotient rule to solve. So letter B is going to be a little bit different than A, and each of them are going to be different. But one of the main things about letter B with the coefficient numbers is that 18 and 20 can't just be simplified automatically to be like 2. 14 over 7 equaled 2, so that I could just put the 2 and be done with it. But 18 over 20 will not work that way. So you have to think about, all right, well, what can I do to simplify that fraction? That's what you would want to do first. So what you're doing is simplifying 18 over 20 like you would in a pre-algebra class. Now, your calculator can do this. In your graphing calculator, if you do 18 divided by 20 and you hit the math button that says math and you hit enter, enter, it'll take every fraction and simplify it in fraction form for you. This is pretty simple. We could divide 18 and 20 both by 2, and that simplifies to be 9/10. So this answer, instead of having 18 over 20 in the answer, I would want to see 9 over 10. So 9 in the numerator and 10 in the denominator like that. You have to simplify your fractions like you normally would, so we can't forget like those types of skills. But then the new skills I'm also going to be looking for are your exponent skills. So I have x to the 7th, y to the 4th on the top, and x to the 3rd on the bottom. I only have like bases with the x variables. So the y to the 4th power is just going to stay y to the 4th power. I will not be using a quotient rule for that one. So I have x to the 7th power over x to the 3rd power. How many x's will I have? X to the what power? After using the quotient rule. 7 minus 3? 4. And that will go in the numerator because there's more, like the 7 minus 3, there's more x's on the top, so x to the 4th will be on the top, and then y to the 4th is also on the top there. Y to the 4th does not have anything to simplify with, so here's what the answer is, but just the format kind of looks weird, the way that I had the 9 over 10 all the way over here on the left. So just to make this look a little bit better, I would probably just put the 10 in the center on the bottom, so it doesn't look so weird. But this is 9x to the 4th, y to the 4th, all over 10. All right, hopefully you're getting the hang of this. What I want you guys to do is try letter C on your own. Just be careful with the double negatives. But first, simplify the fraction coefficients, so the plain numbers, and then go ahead and use the quotient rule only for like bases. You have to use the quotient rule twice in this problem. So I'll give you a couple minutes to simplify that, and then we'll go over it. Alright, so for letter C, the first thing I'm going to do is simplify the fraction, negative 18 over negative 6. So I can simplify this by putting in my calculator or just do it in your head. Negative 18 divided by negative 6, and negative divided by negative is a positive. This is going to equal positive 3. So when you are simplifying this, you can put the 3 on the top. You don't need the 1 on the bottom. It does simplify to be 3 over 1, but you don't necessarily need that. You can just put the 3 on the top, and that's fine. And then working down the line, I'm going to only use the quotient rule when we have the same bases. So m to the 3rd over n to the 1st power on the bottom. So the 1 is there. It's just not written. So this is going to be 3 minus 1, and that is going to leave us with m squared. That will go on the top, on the numerator here, m squared. And then the next one is n to the 6th over n to the 3rd power. We use the quotient rule again. 6 minus 3 is 3, so this is going to be n to the 3rd power. This one doesn't end up being a fraction at all. It ends up just being 3m to the 2nd power times n to the 3rd power. All right, and then moving on to the next couple of problems, we have some examples where we will be using the not just the quotient rule, but the quotient to a power rule. So in letter D, we have a fraction, which is x to the second power over 2y, all being raised to the third power. So I need you to understand that what this actually means, when you raise something to a power, that means that that thing, which is this, is being multiplied by itself 3 times. This is essentially x to the second power over 2y times x to the second power over 2y times x to the second power over 2y. That is really what this is saying. When you raise something to a power, that base, in this case the base is x squared over 2y, is being multiplied by itself 3 times. So this is what's happening, and that's why we use these different rules. The rule said, instead of having to expand it and simplify it from here, the rule says you would take your problem, x squared over 2y to the third power, and you distribute the power to everything inside the fraction. You just have to be very careful that everything gets a power of 3. So the first thing that gets the power of 3 is the x squared. So when you do this, you have to use multiplication. You will take the original exponent 2 and multiply it by its new power 3 to get the final answer as your new exponent. Which if you look at the way that it's expanded up here, it makes sense. X squared, x squared, x squared. Well, this is 2 x's, 2 more, 2 more. There's a total of 6. 2, 4, 6. 2 times 3 is 6. So I know this is going to simplify to be x to the 6th power. So it does make sense when you think about what's happening when you expand it. And then on the denominator, it's very important that you don't forget everything gets the power of 3. So the denominator says 2y, and then you have to distribute the 3 to both the 2 and the y. A lot of times we forget to distribute the 3 to the 2 as well, and students will just put 2 times y to the third, but it's actually going to be 2 to the third power times y to the third power. And 2 to the third power is 2 times 2 times 2. We can see that here, 2 times 2 times 2, that's equal to 8, and y to the third power would just be the answer here. This final thing is x to the 6th power over 8y to the third power. And if you look at the expanded version of this, you can see where these numbers come from. X squared, x squared, x squared. There's 2, 4, 6 of them. That's where this comes from. And I can see 2 times 2 times 2 is 8. I see 1, 2, 3 y's. That's where the y to the third power comes from. So you don't necessarily have to show this. I'm just showing you how the rules work, where they come from. As long as you memorize the process, you'll be good to go. So letter E has us only using a power rule in just the numerator. So this is like the power rule from yesterday. Only the numerator, 2b squared, needs to get a new power of 3. So I need to distribute the 3 to the 2 and the 3 to the b squared. When I do that, this is going to turn into 2 to the third power times b to the 2 times 3. I know I sound like I'm speaking a different language, but what you're doing is you are multiplying the current exponent with the new exponent. And that's going to be all over 4b to the third power. So simplifying this further, 2 to the third power is 2 times 2 times 2, that is 8. b to the 2 times 3 is really just b to the 6th power. And then we have all over 4b to the third power. Well, this one's going to work out nicely because when I go to simplify my coefficient numbers, 8 divided by 4 is 2. And b to the 6th power over b to the third power means there's 6 b's multiplied on the top, 3 on the bottom. 3 on the top will cancel out with 3 on the bottom, leaving us with 3 on the top. And we can get that from the quotient rule. 6 minus 3 is 3. So this will end up being 2 times b to the third power. All right, and then this last one says x to the n power times y to the 3n power all over x squared y to the 4th. So this one's weird because not only do we have variables as bases, but we also have variables as exponents. All the other problems so far, all of the exponents have been numbers, and when we have plain numbers, we can add them, subtract them, we can easily multiply and divide them and not be confused with what the actual answer is, because when you have just numbers, doing operations is easier than if you have variables. But we can still use the same process and the same rules even though we have some variables in different places than normal. So here's the problem again. There's no power to a power rule or quotient to a power rule we have to use, so we can just go ahead and start simplifying this by using the quotient rule. So I'm going to start here with the x's. Unfortunately, we don't know what n stands for, so when I go to simplify this, it's going to be a little bit weird because I normally would take the numerator exponent and subtract the denominator exponent and leave it as x to the answer to that difference, but because we don't know it, it's just going to be x to the n minus 2. I don't know what n is, but I know to simplify it, I would take that number and subtract 2 from it to get that answer. Same thing's going to happen with the y's. When I go to simplify the y's now, I have a variable here that I'm not sure what the answer is, so when I go to simplify this, this is going to be y to the 3n minus 4. And that's all you can do with that. Because we don't know what n is equal to, I can't simplify that further, so that's just what the answer is. And notice I put a little multiplication symbol here because everything with these rules only applies when you're multiplying. So all of these fractions, even though they are being divided, the little terms on each, the numerator and denominator, are being multiplied, and I can tell that because whenever you have numbers and variables next to each other and there is no operation there, visible operation there, we know it means multiplication. So there are 2 practice problems below that I want you to take a few minutes trying on your own. So go ahead and please try those. Be very careful with using the correct rules and doing the correct thing, like subtracting at the correct time or multiplying at the correct time. I'll give you a couple minutes. We'll go over the answers, and then we'll move on to the quizzes practice. All right, so number 1, the first thing I'm going to do is simplify the coefficient numbers. That means the 27 over 9. Well, 27 over 9 simplifies to be 3, so I'm going to write the 3 on the top of this fraction. And then moving on to the m's. This is m to the 5th power over m to the 1st power. 5 minus 1 is 4, so this will be m to the 4th power. And then n to the 6th over n to the 3rd power. 6 minus 3 is 3, so this simplifies to be n to the 3rd power. When this happens and the fraction all ends up canceling out, you could put the 1 underneath of it, or you could just write your final answer as 3m to the 4th times n to the 3rd like that, and you can drop the 1 completely. You only need the fraction if you ever have something in the denominator, if there's numbers that end up in the denominator still, but sometimes they do end up all canceling out. Number 2, we have parentheses, and we have inside the parentheses we have negative 4xy, and that's all being raised to the third power. I want you to realize that when that happens, that means the base is being multiplied by itself 3 times. Negative 4xy, negative 4xy, negative 4xy is being multiplied by itself 3 times. That's what that means. So when we use the power rule, we have to distribute the power of 3 to all of the different terms. So the 3 gets distributed to the negative 4, to the x, and to the y. So when I do that, this turns into negative 4 to the third power, x to the third power, y to the third power. And in the expanded form, you can see that happening because it's negative 4 times negative 4 times negative 4, x times x times x, y times y times y, which that makes sense with those exponents here. And then I'll just write that over 8xy squared. So then the next thing I would want you to do so that we can simplify the coefficient numbers is simplify negative 4 to the third power by putting it into its numerical answer without the exponents. Negative 4 to the third power is negative 4 times negative 4 times negative 4, which is negative 64. So I have negative 64 negative 64x to the third, y to the third over 8xy squared. So then I can simplify the coefficient numbers. Negative 64 divided by 8 is negative 8. X to the third over x to the first would be 3 minus 1, which is going to be x squared. So I would have x squared left. Y to the third over y squared. 3 minus 2 is y to the first power. So my final answer would just be negative 8x squared times y. So